Hello everybody. For this pre-quiz vid, we are going to be graphing best fit lines and finding the equation and then using the equation for some extension questions. So this is a few-part process. What we're after here is an example of a scenario you might encounter. Here we have some data that was recorded measuring the ice cream sales for various outdoor temperatures. This guy over here selling ice cream, come on down. There are different amounts of ice cream sales, though, depending on the temperature. So here we have a table representing that relationship. And then what happened here is the points were plotted. I'm going to give that to you. And then what we want to do is we want to use this graph of the data right there. And we want to draw a best fit line. And we want to find the equation of the model. So that's kind of like the first part of this problem that I'm giving you. So if you're looking at all these data points, obviously it looks like there's a correlation. It looks like it's a positive correlation because this is increasing, and it is I would say it's a pretty tight correlation too. So this is what we have here is on the x-axis, our independent variable is the temperature, and on the y-axis, this is the ice cream sales represented in dollars. So as you can see, as the temperature gets hotter, more and more money is made on ice cream. Makes sense, right? When it's hot out, I want to buy ice cream, and so do lots of people. So the ice cream sales, this guy's feeling pretty happy on a hot day. Okay, so drawing a best fit line, let's do that first. And when I draw my best fit line, I'm going to want to, remember, try to make your line kind of the average of all the points, and you want to have about the same number of points on top as you do on bottom. So this right here is my model for my line of best fit. It measures the trend of the sales. So remember, this isn't exactly what is happening for each one of these data points, but it gives you an approximation. So that part is done. Check. I drew a line of best fit. So now I need to find the equation of the model. To find the equation, I need to grab 2 points off of my line. Off of the line, not off of the data. So let's see. It looks like I've got a pretty decent coordinate here. And I've got a pretty decent coordinate. Let's see. Let's take this one right here. Okay, so that's where my 2 crosshairs, when I'm looking for a coordinate, I want to look for where the crosshairs of my grid lines intersect, and I can pull something from my x and my y coordinates. So let's write these 2 points here. This one is going to be a 12, 200. And this one over here is going to be 24, 600. So I want to find the equation of the model. The model is my best fit line. And to do that, I need to pick 2 points off the line. And now I want to find the equation of this line. So this, at this point, should be review. What we're going to do here is we're going to take the 2 points, and I'm going to rewrite them. 12, 200 and 24, no, I forget what it is, 600. And I want to find the equation of the line given these 2 points. This should be review. So what I'm going to do is I'm going to pause it here, I'm going to do the work, and then we'll catch back up once I've done. All right, I've done all my work here finding my slope and finding my b to give my final equation for this model. If you're having some trouble with it still, go ahead and pause it, take a look at my work, or you can look at the PDF down below and kind of analyze it and see where the gaps are for yourself. Or you can check out the last video if you're still having trouble with this stuff. But what I want to get after here is here's my final equation, and let's think about what this means. So the y value represents my sales, and the x value represents the temperature. And that should make sense because that's what we had in our graph. X is temperature, y is sales. And let's look at this too. My b value, my y-intercept, is negative 199.92. So let's think about that. What that means is that when my temperature is 0, the amount of money I would make would actually be negative. Well, does that look like that's what's going to hit the y-axis here if I continue this line? Well, it doesn't. It looks like it's going to hit around a little over 100. But take a look at your x values. The graph, whoever made this graph, kind of cheated a little bit and started their x at 10 rather than putting a 0 and then a break and then 10. So if you were to follow that trend, I think it would be kind of reasonable to see that graph dip below into the negatives there. Okay, moving on. We have our equation, and we want to use the equation to answer the following questions. So, first one, what would you expect your sales to be, looking for sales, on a day when the temperature reaches 27.2 degrees? So going back to our equation, we want to know the sales, and we have the temperature. So we're going to plug in the temperature and solve for sales. So let's plug it right into the equation. Y equals 33.33 times my temperature, 27.2, and that's minus 199.92. All right, so let's crunch these numbers here. I've got a calculator handy, and 33.33 times 27.2 gives me 906.576. So y equals 906.576. Make sure I got that right. Yep. Minus 199.92. Okay, one last number crunch here. Minus 199.92. So I get 706, and we'll round to, we're dealing with money here, so let's round to the nearest cent. So 706.66. And what that means is that I expect to sell $706.66 worth of ice cream. So right there we used our equation, our model, to find out how much sales we would get if we plugged in this number for x. So we're using our algebra skills, plugging in and solving. Let's take a look at the next equation, or the next problem here. If the ice cream sales for the day totaled to $98, what would you expect the day's temperature to be? So here we're given the sales and we want to know the temperature. So again, we're going to go back to our equation model, and we're going to this time plug in y, substitute y for our sales, and we're going to solve for the x value. So we've got $98, and that's going to equal 33.33 x minus 199.92. All right, at this point I'm going to do the algebra to solve for x, and I'll resume once I do that. So, all right, so I did the algebra out for here, solving for x, and I got 8.94 degrees. And that seems like it's a pretty logical answer for what I should expect my temperature to be if I only am able to sell $98 worth of ice cream. If you were to take a look at the graph and look at where about $98 would be if I were to follow my line in this direction, probably somewhere around here. And it looks like that could be a reasonable amount or a temperature that would register for that day, 8.94 degrees. So it seems to fit with my best fit line model. That's the kind of stuff that we're after here. We're trying to determine a prediction from a general trend of this line. Remember, I'm not actually grabbing specific data points, and I don't know with certainty any of these calculations from the equation model, but I can get a general prediction about the way that these data points are going to go. Just a heads up, the actual quiz that I'm going to give you based upon this stuff will be a little bit different. I'm going to change up some data points. You're not going to see the exact same equation here, but it's going to be very similar. So use this video, ask me questions if you got them. If you want to also check out where I got this from, here's a great resource. It's mathisfun.com, all that stuff. I'll put the link below in the description too. So use this. I hope it's helpful for you. If you got questions, ask them. Alrighty.